Hi students, now we are going to solve the fourth problem in the textbook exercise. The resistance of a nichrome wire at 0 degrees Celsius is 10 ohm. If its temperature coefficient of resistance alpha is 0.004 per degree Celsius, find its resistance at boiling point of water. So boiling point of water means it is 100 degree Celsius, we must know. So what are all the given quantities in the problem? I have to write as a list here. The initial reference temperature is denoted as T0, that is 0 degree Celsius. And at that 0 degree Celsius, the resistance is denoted as R0, that is equal to 10 ohm. Then the higher temperature is boiling point of water, that is 100 degree Celsius. At this temperature, what is the resistance has to be found, that is RT. We have to find out. Given alpha is equal to 0.004 per degree Celsius. Now we have studied that alloys have a positive temperature coefficient of resistance. So as the temperature increases, the resistance also increases. So the formula required for this is resistance at a higher temperature RT is equal to resistance R0 at a lower temperature into 1 plus alpha into T minus T naught. T minus T naught. So this is the equation we are going to use here. So RT is equal, so whatever RT is equal to R0 into direct substitution only. R0 is equal to 10 ohm. So this is equal to R0 is equal to 10 into 1 plus alpha is 0.004 into T minus T naught is 100 minus 0. So this is 100 minus 0 is 100 only. So this is equal to 10 into 1 plus 0.004 into 100. So this is equal to 10 into 1 plus 0.4. So this is equal to 10 into 1 plus 0.4 is 1.4. So this is equal to 14 ohm is the answer. So the resistance, therefore we can write R100 is equal to 14 ohm. So the resistance at the boiling point of water 100 degrees Celsius is equal to 14 ohm. Okay. Hi students. The fifth sum is the rod given below is made of two different materials. Both have square cross sections of 3 mm side. Resistivity of the first material is 4 into 10 power minus 3 ohm meter and it is 25 centimeter long. Resistivity of the second material is 5 into 10 power minus 3 ohm meter and it is 70 centimeter long. So what is the resistance of the entire rod? So this is very excellent numerical problem. Here understanding is very important. Now the materials are different. For the first material the resistivity is different and for the second material the resistivity is different. So we will call them as rho 1 and rho 2. Okay. So the resistivity of the first material, whatever is given in the sum I am going to write now. So rho 1 is the resistivity of the first material, that is 4 into 10 to the power of minus 3 ohm meter, and the length L1 of the first rod is 25 centimeter. So 25 centimeter in meter I am converting, so that this is equal to 0.25 meter. Then specific resistance of the second material is 5 into 10 power minus 3 ohm meter, and the length of the second rod is L2 is equal to 70 centimeter. So this in meter it is 0.7 meter. Now what is common for both? The area of cross section, is it not? It is not circular, it is square cross section. And this square cross section, each side is how much? It is given 3 mm side. So the area of cross section A1 is equal to A2, that is equal to A, and that is equal to what? 3 millimeter into 3 millimeter. So this is equal to 3 millimeter into 3 millimeter. So that it is 9 into 10 to the power of minus 6 meter square. So 1 millimeter is taken as 10 power minus 3 meter. So 10 power minus 3 into 10 power minus 3 is 10 power minus 6 meter square, and 3 into 3 is what? 9. So the area of cross section of both the rods will be the same. Now since they are joined together, the total resistance must be equal to what? R1 plus R2, is it not? R1 plus R2. So I will take now resistance of the first material is R1. So R1 is equal to rho 1 into L1 divided by A. Is it not? Because the area of cross section is the same, I cannot write A1 here. It is A itself. And R2 is now equal to rho 2 into L2 divided by A. Now we have to find the equivalent resistance. Therefore, R equivalent is equal to R1 plus R2, because these two materials are in series. So I am adding their individual resistances. So I am going to substitute here. So this is now equal to rho 1, okay, into L1 divided by A plus rho 2 into L2 divided by A. So now A is common. So this is 1 by A into rho 1 into L1 plus rho 2 into L2. Okay, students. Now we are going to substitute. All these values are given here. I am going to substitute in the bracket. Therefore, R equivalent is equal to 1 divided by, the area is 9 into 10 power minus 6. So in the denominator, 9 into 10 to the power of minus 6 inside the bracket. Now rho 1 into L1. So that is 4 into 10 power minus 3. So this is 4 into 10 power minus 3 into L1 is 0.25. So this is equal to 0.25 plus rho 2 into L2. So rho 2 is 5 into 10 power minus 3. So here 5 into 10 power minus 3 multiplied by 0.7. Once again inside the bracket, 10 power minus 3 is a common factor. So this can be taken out. So this is equal to 10 power minus 3 divided by 9 into 10 power minus 6 into, now first one is 4 into 0.25, 4 into 0.25 plus 5 into 0.7, 5 into 0.7. So this is now equal to this 10 power minus 6, okay, and 10 power minus 3. If you divide means on the top 10 power 3 will come. So this is equal to 10 power 3 divided by 9. Okay, because 10 power minus 6 is in the denominator. When it comes up, it becomes 10 power plus 6. So 10 power plus 6 into minus 3, no, it will become 10 power 3 into, now inside the bracket you see here, 4 into 0.25. 0.25 is what? 1/4. So 4 into 0.25 must be equal to 1. So inside the bracket it is 1 plus 5 into 0.7. 7 5s are 35. Therefore it must be 3.5. So this is equal to 1 plus 3.5. So that this is equal to 10 power 3 into 1 plus 3.5 is 4.5 divided by 9. So this is equal to 4.5 divided by 9 is 2 times. Okay, 2 times. 4.5 into 2 is 9. So this is equal to 10 power 3 is 1000 divided by 2. Therefore, R equivalent is equal to 1000 by 2 is equal to 500 ohm. Is it not? So the total resistance of the entire blocks, two resistors together, okay, the effective resistance or equivalent resistance is equal to 500 ohm. Have you understood? Okay.